What if the most dangerous things in our galaxy are not the stars we can see, but the dead objects silently drifting between them right now? Not exploding, not glowing, not announcing themselves at all. Just dark stellar wreckage. Black holes, neutron stars, white dwarfs, moving through the Milky Way like evidence left behind after billions of years of cosmic violence. And Gaia, the European Space Agency mission built to measure stars with absurd precision, is turning our galaxy into something that looks less like a map and more like a crime scene. This is the idea. If a star vanishes, if another star wobbles for no obvious reason, if a pair of objects move as if something massive is there, but invisible, Gaia can catch the gravitational fingerprint. And that fingerprint hints at a possibility that feels deeply unsettling. The Milky Way may contain millions of dark stellar remnants we almost never see directly. Millions! The black holes themselves are only part of the story. The larger truth is stranger. We may live inside a galaxy filled with the unlit remains of dead stars, and only now are we getting precise enough to notice the gaps they left behind. Personally, that changes the night sky for me. It makes it feel less like a peaceful ceiling of lights and more like a field of buried history. Engaged. Start with one star. A hot, massive star lives fast, burns through its fuel, and dies violently. If it begins with roughly more than 20 solar masses, it can collapse into a black hole. Smaller massive stars can leave neutron stars. Sun-like stars leave white dwarfs. In every case, the bright, visible object is gone. But the corpse remains. That is the what. Dead stars do not simply disappear. They stay in the galaxy as compact, often invisible mass. The how is where Gaia becomes extraordinary. Gaia measures the positions, distances, and motions of more than 1 billion stars. Its early data releases already transformed astrometry. By data release 3, in 2022, astronomers had access to exquisitely precise motions for vast parts of the Milky Way. Precision at the level of micro arcseconds means you can detect a star drifting, wobbling, or accelerating in ways that should not happen if it were alone. Think of it like this. You walk into a room and see a chair sliding slightly across the floor. You do not need to see the person pulling it to know someone is there. Gaia does the same thing with stars. It watches the chair move. And in some cases, the invisible hand may be a black hole. One of the clearest examples arrived in 2022 when an international team using Gaia data reported Gaia BH1, a dormant black hole about 1,560 light years away, published in monthly notices of the Royal Astronomical Society. Its mass was estimated near 9.6 times the Sun. No bright accretion disk, no dramatic feeding, just a sun-like star orbiting something dark and heavy. That mattered because it showed the galaxy can hide black holes in relatively quiet systems. Then came Gaia BH2, reported in 2023, with another dormant black hole candidate in a wide binary. Different system, same message. Black holes do not need to flare to exist. They can sit there, almost polite, detectable only because their gravity betrays them. And if we have found a few in the tiny fraction of parameter space we can currently search well, what does that imply about the ones we are missing? This is where the story becomes less about individual discoveries and more about population. Stellar evolution models have suggested for years that the Milky Way should host millions of stellar mass black holes. A 2020 study led by Pasquale Esposito and collaborators discussed how isolated black holes might be detected through microlensing. Other estimates, including work often cited from Shuyayev, Mignani, and broader population synthesis studies, place the number of stellar black holes in our galaxy somewhere around 10 million to 100 million. The range is wide because black holes are good at being absent from our instruments. And that number sounds abstract until you scale it to human terms. Imagine every city on Earth had thousands of invisible wrecks drifting through it, silent and hard to detect. And the only way to find them was to notice how nearby traffic bends around empty space. That is roughly what galactic archaeology is becoming. There is another clue Gaia helps expose: missing stars. Not literally stars blinking out before our eyes, but expected populations that no longer match simple models. Massive stars should have lived and died all across the Milky Way over billions of years. Their remnants should still be here, yet most are dark. So astronomers reconstruct the dead from the survivors. From velocity kicks, disrupted binaries, runaway stars, and subtle orbital scars. A supernova can kick a remnant outward at tens or even hundreds of kilometers per second. Some remnants remain bound in binaries. Some do not. Some become isolated black holes, drifting through the galactic disk with almost no electromagnetic signature. You could stare at the right patch of sky forever and never know one had crossed it. Doesn't that make the word empty feel a little naive? Gaia's newest precision maps matter now because they sharpen all of this at once. Better parallax means better distance. Better proper motion means cleaner trajectories. Better orbital solutions mean more confidence when a visible star appears to dance with an invisible partner. In 2024, Gaia's expanded catalog and follow-up spectroscopy kept improving the filter astronomers use to separate ordinary binaries from systems with dark companions. This is the why now. We are moving from anecdotes to census work, and I think that is the real shift. For years, black holes felt like rare headline objects, monsters at the centers of galaxies, or spectacular mergers seen by LIGO. Now, the quieter possibility is creeping in. The Milky Way may be littered with ordinary black holes in the statistical sense, not rare wonders, background debris. That, to me, is more disturbing than the cinematic version. So, let me ask you this. What feels more unsettling to you? The black holes we can watch feeding and glowing? Or the silent ones drifting nearby with no warning at all? Tell me in the comments. There is an important caveat. Dangerous does not mean a black hole is about to swallow the solar system. Space is unbelievably vast. Even if the galaxy contains millions of them, the average separation is still enormous. NASA and ESA observations give us no sign of an immediate threat. But safety is not the only reason this matters. Knowledge matters because it changes how we understand the structure of our galaxy. If millions of stellar remnants are wandering the Milky Way, they contribute to its mass budget, its dynamical heating, and the long afterlife of star formation. They tell us how many massive stars were born, how many exploded, how often binaries survived, and how often remnants were kicked loose. Every dark object is a historical record. Every orbit is a witness statement. But there is a deeper implication people often miss. A galaxy is not only made of what shines, it is also made of what has already ended. The visible Milky Way, the dust lanes, the blue stars, the glowing nebula, is just the current cast. Gaia is helping reveal the graveyard beneath the stage. Personally, I find that almost impossible to forget once you see it that way. But that still leaves one uncomfortable question. If these objects are so dark, how do you find the ones with no companion star at all? This is where the story takes a turn. Some of the black holes Gaia may help expose are not orbiting anything bright enough to betray them in a neat binary. They may reveal themselves only when they pass in front of a background star and bend its light. Gravitational microlensing. A brief distortion. A tiny positional shift. A star seems to brighten and move for no obvious reason. Then, the effect is gone. In 2022, teams studying the event MOA 2011 BLG191 and other lensing candidates argued over whether some lenses could be isolated black holes. One famous case, MOA 2011-BLG-191/Ogle analyses, sparked debate because the object seemed massive and dark. That debate matters. It shows the frontier is messy. Gaia is not handing us a neat list of invisible corpses. It is giving us clues, and astronomers still have to argue in public over what the clues mean. And honestly, I love that part. Science here feels less like receiving answers and more like reconstructing a hit and run from tire marks, broken glass, and a bent street sign. There is also a selection problem. Gaia is best at certain distances, brightness ranges, and orbital periods. Some black holes sit in systems too wide, too faint, too face-on, or too chaotic for an easy detection. Others are isolated, revealing themselves only through rare lensing alignments. So when the newest maps suggest a vast hidden population, they are not claiming every object has been found. They are telling us something more subtle. Once your map gets precise enough, the visible galaxy stops adding up, unless you include the dead. Unless you include the dead! And if that idea just changed the way you look at the night sky, leave a like, because realizing the galaxy is full of invisible aftermath is one of those facts that stays with you. So, what is the payoff for us? It is not fear. It is perspective. We tend to imagine the universe through what glows. Stars, galaxies, explosions, color. But much of reality is inferred, not seen. Gravity writes a biography that light often refuses to tell. A child can look up and see constellations. Gaia looks up and sees missing mass, bent trajectories, interrupted families of stars. Which is the truer galaxy? maybe both. One is the Milky Way of human experience. The other is the Milky Way as physics keeps insisting it really is. And if millions of stellar remnants are out there, drifting in darkness, then the galaxy is not just a place of birth. It is a place that remembers death in motion. That sounds poetic, yes, but it is also a measurable astrophysical fact. White dwarfs, neutron stars, black holes, they are the archive left by earlier generations of stars. The night above you is not only alive, it is haunted by what used to burn. Can you imagine how many ancient systems had to live and die to create that invisible population? Can you imagine how many companions were flung away, how many orbits were broken, how many stellar lives ended quietly enough that only precision mapping can uncover them now? That may be Gaia's most unsettling gift. Not a prettier map, a more honest one. A Milky Way where the darkness is structured, populated, and full of evidence. A galaxy that looks calm to our eyes, but under precision measurement, reads like a forensic report written over billions of years. So the next time you look up, remember this. The stars are only the visible testimony. Around them may drift the compact remains of suns that already finished their story, still shaping motions, still bending light, still leaving fingerprints in a sky that seems empty only because our eyes are too old-fashioned to see the whole case. If the hidden architecture of the universe fascinates you, subscribe, because out there, the cosmos keeps far more secrets in the dark than in the light.